Hello, 7th graders. Welcome to your last lesson in Chapter 3. 3.7. I can graph rational numbers on the coordinate plane. I can find the distance between 2 points on the coordinate plane. So, following along on 173, here we go. You should have some graph paper. I did give you some in class. If you don't have any, you could probably Google it and print some out, or you might just gonna take some time, use a ruler, and it's gonna take you a little bit longer to do some notes. But you're gonna need a coordinate plane to be able to follow along. So, distance on a coordinate plane. This is a coordinate plane. It's made up of 4 quadrants. At the center, 0, 0, this is your origin, center of a coordinate plane. This is your x-axis. It has positives to the right, negatives to the left. Your y-axis is vertical. Positives are up, negatives are down. Coordinate plane, you plot points by using an ordered pair, which is made up of x and then y, and you do things left and right first, up and down second. Negative numbers tell you to move left, positive numbers tell you to move right on the x-axis. On the y-axis, positive numbers are up, negative numbers are down. So if I were to plot this point negative 3, 1, since negative 3 is first, I actually go 1, 2, 3 to the left and 1 up, and that is why that its coordinate is negative 3, 1. For positive 2, 3, I go to the right 2, up 3. For negative 1.5 and negative 2.5, I go to the left, negative 1.5, and down 2 and 1/2. This is a coordinate system. Again, like I said, this is the origin. An ordered pair is x and then y. X is horizontal. Quadrants there are 4 of them. They go 1 through 4 counterclockwise, starting in the upper right. So 1, 2, 3, and 4. In quadrant 3, both parts of the ordered pair are negative. In quadrant 1, both are positive, and there's a mixture in these two. So if you are just given a point, you should be able to name the ordered pair, and you can do that by first looking from the origin. You always start here, counting how many places you go left or right. So I go to the right 1. Notice, I shouldn't just count. Notice this is 1 here, so this must just be half. So I go 1 whole unit, 2 whole units, 3, and it looks like just 1/2 of the way. And then I go up 1 and a full 2. And we can look here. So I start at the origin, just like it said. I like to do things twice today so that you get a good handle. Start at the origin, move right to the x coordinate. So 1, 2, 3.5. Notice. And then we move up to the y coordinate, which is 2, 1, 2. So our ordered pairs are x value of 3.5 and our y value of 2. So if you want to give that a try on this one, name the ordered pair for each point. So what this means is it shows you this, and you'll see this on your assignment, and you want to name the ordered pair for each of these. So where is J? So what I'm going to do is start at the origin, and I'm going to go negative 1, and then it looks like negative 1.5. So I already know my x is negative 1 and 1/2. And from there to go up my y value, I go up 1 and a full 2. Okay? So then I can go again. Now I'm going to look for K. And I'm going to start at the origin again. And I see that I go over 1, because this is 1/2, and then up 1/2. So to the right, I went 1. It's positive because I went to the right. And up and down my y-axis, I went up 1/2 of the way to 1. Ordered pair for point L. Starting again at the origin. Looks like I would go to the left, or to the right, sorry. 1, 2, and 1/2. I went to the right, 2 and 1/2. And to get down on my y-axis, I went down 1/2, so that'd be a negative 1/2. Lastly then, to find my point for M, I'm doing lots of multiple colors today. I see that M's over here, so I have to go to the left. 1, 2.5, so I went over left, which would make it a negative, 2 and 1/2, and I went down to make it another negative, down 1, 2 and 1/2. Normally on a grid, these usually represent 1. You can change your intervals if there's no numbers so that it does go by 1/2, and that might make it easier if it's a small space. Hopefully that helps. Left and right, up and down. Left and right first, up and down second, and then you write them. If it's left, negative. If it's right, positive, and so on and so forth. So now if you're given a point and you're asked to graph and label it, first thing you're going to need is this when your graph paper, again, will come in handy. So if you have your graph paper out, that'd be a good thing to have. Make sure your intervals, whatever they are spaced out, because notice here, last time we went by 1/2 for each square. This time it looks like we're going by 1/4. So we'd have, 25/100, 5/10, 75/100, and then 1 is 1, 2, 3, 4 units up. So just make sure you're aware of the intervals that you're using so that you're counting correctly. So I start at the origin, and then it says 1/2, and this is my x, so I'm going to go 1/2 to the right, and it says 1 75/100 for y, so that's a positive, so I go up 1 and 75/100, so I can go up by 25/100, and that's where my point A will be. I went x, and I went y. I drew a dot, and I labeled it A with its coordinates. This is very important. Make sure you do that. So if I want to try this one, -2, -3 and 1/4. Again, I'd start at my origin. Since it's -2, I go over 1, 2. Notice this is going by ones now. Just make sure you're aware of your intervals here. So I go over 1, 2, negative to the left. Then I move down 3, 1, 2, 3, and 1/4 of the way. Or we know 1/4 is the same as 25/100. So it's about a quarter of the way to the next one. I draw a dot and I label it with its coordinates. You could try to do these ones now. Give those a try on your own. You could pause and come back, whatever works for you. Looks like I'm going to have a red dot here. So what I'm going to do is, with my dot, I'm going to start at the origin. I'm going to go, since it's 2 and 1/4, I'm going to go over 2 and up 1/4. Just kidding, 2, not up 1/4. I'm going to go, starting over, sorry. I'm at 2 and 1/4 here, and that's my x. So I'm going to go to the right that way. 1, 2, and 1/4 over. So I'm not quite on 2. I'm not on 3. I'm 1/4 of the way. And then I'm going to go up 3 1/2. So I'm going to go up 1, 2, 3, and then halfway between 3 and 4. Put it there. Then I would label this, put my point, and label it R 2 and 1/4, 3 and 1/2. That's my ordered pair for that point. So over here I have S, -1 1/2, 3. So I start at the origin always. I go left -1 1/2 because it's the x-axis, and it's -1 1/2. From there I'm going to go up 3 since it's a positive y. 1, 2, 3. So now I'm at -1 1/2, 3, and I label my point. I'm going to use green this time with S, -1 1/2, 3. Last one for T. Start my points at 0, the origin, and I'm going to go to the left 1/2, not quite to 1. And then it says I'm going to go down 1, 2, 3, and 3/4 of the way, not quite to 4, but nearly there. And I would mark and label my point with T and the ordered pair coordinates of -1 1/2, -3, and 3/4. Ta-da! So more. Now we're going to use that Pythagorean theorem, which you love so much, to find the distance between 2 points on the coordinate plane. Notice when we graph ordered pairs 3, 0, and 7, -5, we form this line segment when we connect them, but we also can see how far away they are. We can make a right triangle, and we can make those legs. So we notice that we have A and B, and we can label this side C because it's a diagonal, it's the hypotenuse opposite of that right angle. So if we know A is 4 and we know B is 5, we can replace them for A and B in the Pythagorean theorem. Evaluate, 4 squared is 16, 5 squared is 25, added together is 41. So this dimension squared is 41. So I take the square root, and I end up with approximately 6 4/10, and it's a positive or negative because it's a distance here. So the points are about 6.4 units apart. Whether it's positive or negative, that's how many units apart they are. So for this one, give these a try. We're going to use those dots, if we will. So I'm going to start, we'll use purple for this one. So I'm going to go, starting at the origin, I'm going to go 2 to the right and 0 up. I'm going to go 5 to the right. So that was this point. I'm going to go 5 to the right now and 4 down. And it looks like I'm looking for the distance from this point to this point. Maybe I should draw a line instead. That might be nifty. So what I'm looking for then is this value, and I could mark it as C because I could find which pen do I want to use, you guys? How about I just use a dash line like this? I need to find my A and B values, so I can go over to 2 and up to 0 and count how many units that is. So I could have my A value here of -4 and my value here of 3, the distance from 2 to 5. So I'm using A squared plus B squared equals C squared. When I'm looking for C, so I can plug in A. In this case, I'm going to make 4 my A. So -4 squared plus B, which is 3 squared, is equal to C squared. Oh, this mouse. So then I can evaluate and find out what C squared is. -4 times -4 is a positive 16. 3 squared is 9. And this all is going to be equal to whatever C is times itself. So that's 25 equal to C squared. Take the square root. And I get that the value C is plus or minus 5. So that means that these points are 5 units from one another. Wahoo! Want to give that other one a try? And bring it with you. Bring two questions or 2 things you've learned in one question. Bring your notes. Please remember to do the Naiku. Watch the video, look at examples, other resources. You know all of them, and I'm really hoping that we're taking advantage of these things that we provide for you and that you are doing your best to develop your understanding. Come with questions. See you then.